right, guys, we started talking in class about transformations. We talked about translations, reflections, rotations, and dilations. Different ways that we can change a shape and either move it in a coordinate plane or shrink it and stretch it, flip it around, rotate it. Well, today we're going to talk a little bit more about transformations and what they mean to us in geometry. So the first thing is translations, reflections, and rotations are called isometries, because the image is congruent to the pre-image. So what that means is if we translate it, move it across a coordinate plane, if we reflect it, which means we flip it over, find the mirror image, or if we rotate it and turn it around, no matter what if we do those three things, then the image and the pre-image are always congruent to one another. Now, when we have a dilation, we stretch and shrink it. Obviously, those are not congruent. Okay, so the first diagram starts with two boxes, and we have a black square and a blue square. And if you look at those letters, on the black square it says A, B, C, and D. And then on the blue square, you'll notice that they have a little tick mark behind it for A prime, B prime, C prime, and D prime. So the black box is our pre-image and the blue box is our image. So what did we do to that black square to move it and make it the blue square? So we moved 4 units to the right and 2 units down. So left and right would be my x coordinate, up and down would be my y coordinate. So we added 4 to x and we subtracted 2 from y. So we can write that in what we call an algebraic rule, and we can say x comma y, and we put our little arrow. We have x plus 4, y minus 2, and that just tells us for every x value we're going to add 4 to it. We're going to move it to the right 4, and for every y value we're going to subtract 2, so we're going to move it down. Alright, so the next example, it says finding the image of a translation. So we start out with this triangle, and it tells us our rule is x minus 2, y minus 5. And we're going to graph the new image. So the first thing I want you to do is let's find the new coordinates. And so the rule tells us again right here that we're going to move x minus 2. So if we say x minus 2, that means we're going to move to the left 2, and y minus 5 means we're going to move down 5. So for P, I would say 2 minus 2, so that's going to give me 0. And for y, I'm going to say 1 minus 5, so that's going to give me negative 4. For Q, that's going to give me 3 minus 2, which is 1. And 3 minus 5, which is negative 2. And I want you to go ahead and take a second and do R. And you should have gotten negative 3, negative 2. So when we graph this image, we're going to use these new ordered pairs in order to graph our new triangle. So P prime is going to be 0, negative 4. And Q prime is going to be 1, negative 2. And R prime is going to be negative 3, negative 2. And our new triangle, our image, is still congruent to our pre-image, RQP. All right, there are 3 ways to write a translation. We're really only going to use the first 2, but I'm going to show you all three. The first one that we're going to use is the algebraic rule. And that's where we have p x comma y then we have our arrow, and p prime is going to be x plus a, y plus b. Whenever we have to do our x and our y, we write that down. The next type is really our shorthand, and so we call that just TAB, which stands for our transformation, and then whatever we do to A and B. And the last one is vector notation, which we really won't do, but I'll show it on here for you. So, for example, a translation that moves a point 4 units to the right and 3 units down can be written as follows. So if we move 4 units to the right, we're adding 4. If we move 3 units down, we're subtracting 3. So as an algebraic rule, we would write p prime is going to be x plus 4, y minus 3. Or as shorthand, we'll have t 4 comma negative 3. And in vector, then it would just be 4 negative 3. Again, you'll just be responsible for the first two. All right, so for this example, writing a rule to describe a translation. What is a rule that describes the translation PQRS, and then it goes to P prime, Q prime, R prime, and S prime. All right, so let's see what happens. So to go from P to P prime, we go over 1, 2, 3, 4, 5, 6, 7, 8 units to the right, and we go 2 units down. So we go plus 8 and minus 2. So our x value changes plus 8, and our y value changes minus 2. So I would write P, xy, put my little arrow, P prime, x plus 8, y minus 2. Or our little translation, 8 comma negative 2. All right, I want you to pause the video, and I want you to try this problem, and then come back and let's see if you get it correct. Okay, it says graph the image of the figure CAT. So C is at 1, negative 2. A is at negative 2, 1. And T is at negative 3, 3. Excuse me, negative 3, negative 3. So this is my pre-image. Then we want to graph the new image where we move 1 unit to the left and 2 units up. So that means our x is going to be minus 1, and our y is going to be plus 2. So if we were going to write this, we would say P of x comma y. So my P prime is going to be x minus 1, y plus 2. So let's write some new ordered pairs. So C prime, we started at 1, negative 2. So if we subtract 1, we're going to be at 0. If we add 2, we're going to be at 0 again. So we're going to be at the origin for C prime. A prime, we're going to be at negative 3, 3. And T prime, we're going to be at negative 4, negative 1. So we've got to plot these new ordered pairs. 0, 0 is C prime. -3, +3 is A prime. And -4, -1 is T prime. So the blue is our pre-image, the red is our image, and those shapes are congruent because all we did was move them on the coordinate plane. Okay, so you should now be able to work your practice problems. I gave you which numbers to do in class, and then I also gave you the answer key for you to check. If you have any questions, of course, you can email me or you can ask me in class tomorrow.